super glad to be moderating this discussion with my two colleagues, Dr. Najwa Aaraj, CEO of the Technology Innovation Institute, and Janne Hirvimies, the CTO of Quantum Gate. Let me give you a little bit of context about our organization because we are in fact colleagues. My name is Reda Nidhakou and I lead VentureOne, which is the commercialization arm of ATRC, the Advanced Technology Research Council, which is in charge in Abu Dhabi of bringing advanced tech and doing applied research from strategy to execution all the way to commercialization. The Technology Innovation Institute that Dr. Najwa leads is actually the backbone of ATRC. This is where all the research happens. It is composed of 10 research centers. One of them is specialized in cryptography, and this is the topic of our panel today. VentureOne is the commercialization arm that builds ventures out of the technology created from VentureOne, from TII. One of the technologies and one of the ventures that we've launched recently is called Quantum Gate, and Janne leads the technology aspects of that company. So let me start by asking Dr. Najwa about the threat of quantum computers. We've been hearing a lot that the quantum computer is coming in the next 5-10 years and that it will threaten the classic cryptography. Dr. Najwa, can you tell us more about this threat and why should organizations act now about this?
Sure. So first, thanks for the introduction, Reda. The quantum computers, there is no doubt that, once they are stable, once they can do large amounts of computations, will be very helpful. And they will enable to advance lots of technological domains tremendously. In terms of cryptography, due to the Shor algorithm, today the two most commonly used public key cryptography algorithm, both the RSA and the elliptic curve cryptography, they are based on two hard problems that we call the intractable problems. ECC is based on discrete logarithm and RSA is based on integer factorization. These two problems, they have a specific complexity when we talk about complexity theory that the current computers cannot break down. However, since they are in this, what we call the BPP complexity class, or the bounded error probabilistic polynomial class, this can be broken by the quantum computer. So this means that once we have this crypto-able quantum computer, which doesn't exist today, which will exist in a few years' time down the line, those algorithms will be broken. The problem is today 70%, even 75% of what we use in terms of security and cryptography is based on those two algorithms. So all of us know HTTPS, SSL, VPN, IPsec, the protocols that Skype use, that WhatsApp use, all of these, the public layer is the first one that is used for authentication and for key exchange, and these will be broken. So this means that our information is at risk because of the quantum computer. Now, today, this quantum computer doesn't exist. However, if you think about most of our organizations, whether we're talking about critical infrastructure, to government organizations, to healthcare organizations, etc., we store data for a long time. So we store data for 10 years, 20 years, and 30 years. This data today, we're either encrypting it using keys that have been generated using those two vulnerable algorithms, or actually they are encrypted using those two vulnerable algorithms. We store it on our servers today. The quantum computer is ready in 15 to 20 years. The attacker that has access to the quantum computer, and these will be very serious attackers initially, they can go back to this data and then they can decrypt it. So we're advocating for the move to post-quantum crypto yesterday, actually not even today or tomorrow, so that we can protect the data that we are encrypting today and then we store it today. And this is what we call the store now, decrypt later phenomena, which we're trying to protect against. So that's in a summary.
Thank you, Dr. Najwa. I think the message is clear. Our data is at risk today because of two things. One, is sensitive data today may still be sensitive in the future, and second, it takes time to migrate to these new post-quantum crypto and so on. Dr. Najwa, I know the TII, Technology Innovation Institute, has been working actually on post-quantum crypto for the last couple of years. So this is a topic that's very close to your heart. Can you tell the audience the work that has been done in the Crypto Research Center so far in this domain?
Today, the mission of the Crypto Research Center at CII is to develop sovereign cryptographic technologies, but at the same time advance most of the topics that the research community and the cryptographic community is working on. In particular, in post-quantum crypto, we have been working on this for a while, and in fact, we were one of the first groups that has developed the first software post-quantum crypto library and the hardware post-quantum crypto library. To get into a bit of detail, today what we're doing is, along with the entire cryptographic community, we're trying to find the alternative schemes that will be used instead of RSA and ACC. And for those to be quantum resistant, this means that the underlying math and mathematical properties have to be in a complexity class higher than BPP or higher than the class that the quantum computers can break, or the Bayes-Shor algorithm or any other quantum algorithm that may come later. So we have invested time to develop and also to implement what the community overall has contributed into a few classes. One is lattice-based crypto. So this is where we have implemented that. It's based on 3 hard problems. We have invested time to work on code-based crypto. And McAllis is actually one of the first algorithms that has been contributed by the community, and we took it further. We've invested into multivariate-based crypto, into hash-based crypto, and then lately we're working also on what we call the permuted kernel, and this is PKP. So in addition to the work that we have developed, in addition to those libraries that we have designed, developed, tested, and taken to a maturity, to a very high technology level, the team is very active in contributing candidates to standards. So we have participated in the NIST competitions as well. And in the last competition, the 2003 competition, I'm happy to say that we went already through the filters of NIST. So this is a competition that started in July 2023. Then there was a first filtering, and the team contributed 7 schemes at that point. And all the 7 has passed. Round 2 happened, I think, a month ago, and only 14 algorithms made it out of the 50 that were submitted initially, and TII has contributed to 5 of them. So 5 out of the 14 has been contributed by a team with TII, of course, in collaboration with others. In addition to all of that, we're also looking into hardware implementations and integration of post-quantum crypto, and we have started looking with various authorities here on how we can start with this migration and the integration of the software and the hardware crypto library in actual real systems.
Super clear. I think there is no doubt that you've gathered a very strong crypto team that works both in libraries but also in setting global standards. Now the question is, what does it take to move from this to production grade security solutions that companies can actually implement?
It's a very good question. And this is what I tell the team all the time, is that the math, the design, writing an algorithm is very hard, but it's not the hardest part, actually. It is how can you take a library and move it to a production level system. So today, if we go, we say, okay, we have a cryptographic library that we have developed, you will feel that there is hesitation. Okay, what do I do with this thing, right? So the first thing is you need to get the library to a level that it has been solidly tested from both a cryptographic perspective and from an implementation perspective. So today, if you look at the team that we have internally, we have, of course, the cryptographers, the guys that work on the design. A lot of them have this mathematical background, etc. But we have a very big team that works on cryptanalysis, both the theoretical cryptanalysis in order to do all the various tests that we do in order to make sure that the math, the logic, and the algorithm makes sense from a theoretical perspective, we have the team that implements the algorithm, and their counterpart is the guys, the applied cryptanalysts. So these are the guys that make sure that we have implemented the right countermeasures in the development of the library, that it is resistant to side channel, that it is resistant to fault attacks, etc., etc. Along the way, you need to make sure that while we're developing the library, we're following a secure software development life cycle. So the same way that you develop your software in order to become a production-grade tool, also cryptographic libraries have to be developed in a way. And of course, there's a way to package them as an API. There is a way to integrate them with an entire pipeline of QA, of DevOps, CI/CD, etc.
Thank you. Maybe just for the audience context, while Dr. Najwa has led this crypto research center, she also incubated on stealth mode a product team for the last 2 years to actually build solutions on top of this crypto. 10 days back, we actually launched a full-fledged venture that will productize and commercialize these solutions. And maybe back to you, Janne, I would like you to explain the solutions that this venture is bringing to the table and how these solutions can elevate the security posture of organizations.
Thank you, Reda. Glad to be here today in front of you. As you mentioned, we launched ourselves 10 days ago, so we are kind of the new startup. But as you also mentioned, this technology has been in the works, I would say, several years. Partially based on the great work that the CRC crypto team has been doing, and besides that, there's been already a product team past 2 years working on. So maybe it's also worth mentioning that there's also another, on the government level, exciting things happening here in UAE. UAE is kind of taking the leader position when it comes to the post-quantum preparation and also the regulation. So following this, we are now, besides launching the venture, we are launching 2 product families. One product family concentrating and focusing to the data security and secure connectivity, and another one focusing to the identity and access management. And of course, as mentioned, both of them are coming from the angle that we are securing the organizations for the future. And as also mentioned, it's not if something is happening, it's more question of when do we have commercially available quantum computers, and then basically all of the existing solutions become obsolete. More specifically on our product portfolio, and this is just a starting point for our product portfolio. So data security-wise, we have a post-quantum VPN solution, and then data security solution that's, I would describe it, enterprise ready, so that we are not necessarily we try to be agile and lightweighted so that we can be adapted and integrated or over top of the existing solutions. Not that we're talking about something that you need to replace completely your system and then start using the, our applications. We also trying to cover the whole landscape from mobile to laptops to Mac to Windows. And then the other product family is actually quite exciting. If you allow me to say, the data security is a bit boring from the user perspective. But the other solution we are bringing is we all have a problem and hassle with our passwords, right? So we have too many passwords. We need to change these too frequently. They are too complex, or at least IT department hopes that they are complex. In practice, they are most probably my dog name, my son's birthday or combination of these two great things. So they are actually very easily guessable. And this is the topic where we are focusing. So instead of user trying to work through all of these, different phases of the password management, there is a secure solution running on your mobile phone and taking care of your passwords, and also, of course, working, with the solutions that don't use the passwords. We call it password-less authentication.
Clear. I think what I hear is agility and easy integration is perhaps one of the key differentiators that you're bringing to the table. What are other differentiators that the solutions we are working on are bringing to organizations? How different is this? Why? How to convince companies that they need to replace whatever they're using today with a new security solution?
Thank you, Reda. This is also a very valid question. As Dr. Najwa here mentioned, the Shor algorithm was published in '93. So basically, last 30 years we've known that the day will come. And as said, these current solutions won't be a little broken. They will become obsolete. How much time we have left is that's a little bit of a guesswork, but we're looking for 5 to 10 years. The question is, what's your data validity in your enterprise or in your government? For sure, the data validity is longer than 5 years. I've been working past 2 decades, system security in general, from hardware, platforms, communication, and this is a huge transition. All of my professional life, the crypto side has been the stable one, and that's been the stable rock. The things are moving, needle is moving very, very slowly. Now we really need to speed up, hurry up. NIST published the first algorithms, or the official, of course the algorithms have been in the works, but now they are officially approved just recently. Data migration, as you mentioned, will take some time. Our differentiating factor is that we've been already working with these things last 2 years. We are ready. Besides that, I'm saying we are ready. We also anticipated the forthcoming challenges in the sense that we're talking about the new cryptography here. So we need to be agile in order to anticipate that maybe this wasn't the final version of the algorithm. That's built into our product portfolio. The second thing is that we're taking so-called hybrid approach. So we're combining best of the both sides. Let's say that the current version of the algorithm, post-quantum algorithm, is vulnerable in some way. We're still using the classic part of the algorithm, and in order to, let's say, break the communication security, you need to, compromise both sides. Enterprise readiness is, as mentioned, is one of the key differentiators.
Clear. I think both of you kind of make it sound like if it was a walk in the park and we just need to implement these solutions. I would like the audience to hear from what are the foreseen challenges in actually moving to such solutions, whether it's from a vendor perspective building the solutions or from organizations that will adopt. Maybe let's start with Dr. Najwa, because I know she's been in this domain for long, and I'm interested also to hear from you, Janne, on this.
Sure. I think, as you said, it's not going to be a walk in the park, right? So today, companies, organizations, government entities, they have to start moving from the classical crypto to the post-quantum crypto, potentially going through the stage of going to a hybrid crypto organizations. I can guarantee to a very high percentage that if you walk today in any organization and you tell them what are the cryptographic assets that you have over here, that you will not get an accurate question. The first thing that you need to do is to go and do an inventory of what are the cryptographic assets that are in the entire organization. And to the surprise of many of us, or the lack of surprise to many of us, is that you will see that a lot of those crypto systems, they will anyway be deprecated. Even from a classical sense, they will be deprecated. So there is a lot of legacy systems that exist that organizations may not be aware of, that we need to find out. So there is a discovery phase. There is a phase where we need to build an inventory of what exists in this organization. There's a second phase to get them to a specific standard, even from a classical sense, and then start to move to the post-quantum part. There is also so this is from, let's say, governance, inventory, identifying what are the assets, and of course identifying the assets that need to move. There's also another technical challenge, is that today if you look at protocols, just to make it at a simplified level, today when we do the key exchange, we use what we call the Diffie-Hellman, even Diffie-Hellman using the RSA, or EC Diffie-Hellman, which is the elliptic curve Diffie-Hellman, and this is an interactive process. The way that key exchange, which in the quantum sense it's called, the post-quantum sense it's called key encapsulation, works is different. So sometimes at the protocol level, you need to rework on how the protocol is happening. So this is more from a technical perspective. There is also the other aspect, which is also a technical challenge, is that today if I need to implement public key cryptography, I have two options. I have RSA and ECC. Typically, ECC provides you with the same bit level of security for a lower number of keys, but you have those two candidates and you choose which one to go with. For the post-quantum candidates, besides the fact that you still don't have all the standards that you need, each one of them gives you a variety, meaning that if you talk about lattices, these would be more suitable for exchanging data and for communication, probably. If you talk about codes, whereas we know that they work because McCallis has existed for a long time and a lot of analysis happens, the public key size is very big. So it might not be suitable for specific applications. So there's also this step back to identify which algorithms have to be used, and then go and talk about this migration. And I think, if I may add, the beauty of Quantum Gate is that it offers all of these, and this is another, if I may add to what Janne said, is that this is another differentiating point, is that you have APIs to all of these, and depending on the use case, you would be able to use one versus the other because of the judgment to use it. And the last point, if I may, is also as you're moving from classical to post-quantum, you need to make sure that you still maintain interoperability. The last thing you want to go is to go to an organization and disrupt what they have because you're doing migration. So for me, these are the challenges that I see in this migration.
Thank you. Janne?
Yes, thank you. Everything what Dr. Najwa mentioned is very valid. And then we have tons of practical challenges. So enterprise environments these days are extremely even more complicated than they were 5-10 years ago. So we have cloud, we have on-prem, we have combination of these two things, and none of us wants disruption there. So we're talking about very fundamental things, because it's the how do we connect, how we secure the connectivity, how we secure the data. So interoperability, usability, performance, these are the things. But it's not actually that's only half of the story, because then we have how do we manage these things, basically what are the integration points, and then there's of course SOC and NOC level, where how do you report different things, and of course the organization CISOs are expecting that all of the following is smoothly covered when you come with your solution.
Okay. We still have 2 minutes. I don't want us to end talking about challenges. Dr. Najwa, what's next in the cryptography world? What excites you today? You've been in this domain for a long time. We've been talking about post-quantum crypto, but what else is there? What's next?
obviously, keeping up with the progress of post-quantum crypto, upgrading the algorithms we have, upgrading the libraries and feeding them in quantum gate is one of the main things we will be focusing on. But there's another area which is very dear to my heart, and I think this is where the real innovation in crypto is anything that has to do with privacy-preserving machine learning. So just to give an example, today, when you want to access data in the cloud, when you want to process data, even if you're securing it with the most advanced cryptographic algorithms, at some point you have to decrypt it to do something on it. There is the other side, there is this whole, let's say, research on privacy that we're doing, and fully homomorphic encryption, for example, is one of the schemes that allows you to keep the data encrypted and then do operations on top of it. So this is an area which we're investing heavily in TII, and I'm happy to say that we're as advanced as everywhere else, and we're starting to do applications on top of it, which is beautiful. FHE, of course, remains very challenging because it's very computationally complex, and we're working both on the algorithmic improvements, but at the same time we're also looking at providing hardware accelerators and hardware optimization, etc. Another area also which goes along the same token is today with this whole, let's say, very big advancements in machine learning models and large language models that we see how much progress they have done, security and cryptography have to follow suit. So we're working on development of cryptographic structures and algorithms for private inference, for private aggregation, for looking into the security of federated learning in order to, and I am a strong believer in this, that if you don't have security at some point, you will face a lot of resistance in the usage of the models, especially the hosted models. So we're working on the security and the cryptographic aspects of that, also in order to boost the adoption of these models that are coming out. So these are the main areas we're focusing on now.
Thank you, Dr. Najwa. Thank you, Janne, for all the insights. I think forward-looking things like AI and quantum computers will in fact help security and actually increase our ability to strengthen our security, but it will also challenge security, as we were talking about. I guess all these technologies, whether it's AI or things like FHE and so on, are in fact very hungry when it comes to compute and so on, and this is another domain that actually we're working on the Technology Innovation Institute. So thank you very much for your insights. I guess we have time to take a couple of questions from the audience. If you'd like to ask Janne, Dr. Najwa.
Thank you so much. Thank you, Dr. Najwa, Reda, Janne, sharing your insights, both technical aspects and the challenges. So the computational power is increasing exponentially, not linearly in the world, like with Moore's law. Maybe in 10 years, we will all have the internet all around the world. And if we look just 40 years ago, we would pay thousands of dollars with the storage machines from IBM. Now we just pay $20 with gigabytes. What I mean is computational power is increasing, and then information sharing is so fast. So we need that encryption policies to protect us. What are the policies that could be improved in your perspective in this field? And my second question is just quickly, the nature of the XPANSE. I met too many next generations. As a role model in the field, what could be your message to the next generations to involve in this field? Thank you.
Let me take this. Ozan, I think this is a very relevant question, the first one on policies. And I'm happy you asked this question because we didn't touch on it. The UAE is one of the first countries that have launched a crypto migration law. This was launched November last year. And last week in CyberQ, which the Cybersecurity Council organized along with Quantum Gate and TII, also His Excellency Mohammed Al-Kuwaiti announced that there will be executive regulations that are coming as an appendix to this law. And these executive regulations, basically, they will be very clear directions on the migration to stronger crypto and then post-quantum crypto. And I'm a very big advocate of these laws and regulations, that countries have to start putting them in order to make the infrastructure, the systems, the networks, etc., ready for this quantum era. Now, the second part to your question has to do with standards, right? So you see today there's I think very good efforts from the NIST to start putting the standard for PQC. If you look at when AES was standardized, this was years after years after years after putting the standardization for symmetric cryptography. NIST has started in 2016 for the standards for post-quantum crypto. Last year, for 2023, they augmented it with the digital signature call, but this will be the case for many years to come until they come to stabilize. And you see that every year, you see that the bit level of security and the parameters of the algorithms, even the standardized ones, they are being strengthened and increased. Having said that, those standards have to be followed, and you have to have appendices. So if you look, for example, at all the FIPS, these 140-2, 140-3, etc., all of these will have to be augmented with post-quantum, and in fact, they are being augmented for post-quantum. Tangentially, today you see what NIST is doing. They're putting standards for cloud computing, and post-quantum will make its way into the cloud computing standards and policy standards, and eventually the policies as well. You have the machine-to-machine, the IoT security. All of these will go there. So this is on the standards and policies. I think what is very important also when it comes to post-quantum crypto is that you have cross-exchange of information, and you have committees that are cross countries in order to start sharing knowledge on this post-quantum. Because the minute, well, first we have to be ready from now, but you will see that the closer the error correction rates on the quantum computers are being tackled, and the closer the quantum computer is viable with a very high number of physical and logical qubits, you will see the panic when it comes to cybersecurity, right? And this is why here we're being very proactive. So exchange of information, putting the processes for migration, etc., is very important. I have a very simple message to the next generations, and I see some in the audience, is we need to be ready to be the future and to build the future of these advanced technologies. So STEM is very important, focusing on math, focusing on physics, focusing on these foundational topics for us to have the theoretical base to be able to advance advanced technologies faster is very important.